Hello guys, welcome back. I hope you watched the previous video where you have understood in that video why we choose microservices architecture, or you can say decoupling architecture instead of monolithic architecture. So whenever we are using monolithic architecture, we may face two major issues. Those are one, application. Since these all layers are tightly coupled with each other, all application dependencies are tightly dependent on tightly dependent. So if one application dependency fails, then it may also cause other application dependency failure also. And one more issue we faced while using this monolithic architecture is, if one application failure may cause other application failure also. Sometimes our application dependencies may not allow other application dependencies to install, right? So in order to overcome these issues, we use microservice architecture, or in detail, we can say we use decoupling architecture. Now, if you use decoupling architecture, it also overcome one more issue, that is scaling. In monolithic architecture, scaling is scaling of individual applications or services is also a difficult task without affecting other components of your infrastructure. The scaling of individual application is difficult in monolithic architecture because all your dependencies are integrated, right? That means tightly coupled, right? So it is difficult in this monolithic architecture. Whereas if you see microservice architecture, or you can say decoupling architecture, there it will be easy. We can able to overcome the issue, that is scaling issue, when you use this decoupling architecture. In this decoupling architecture, we can even scale our individual servers or components or applications easily without even affecting other components of our infrastructure. So why? How? Because our other components are present in other microservices. So that's why if we scale this microservice and its dependencies, then it won't affect the other services. So this decoupling facility will also provide me this scaling availability. So to overcome the issues, we move to decoupling architecture, right? Yeah. So in order to increase the destination's connectivity. So how this decoupling architecture is achieved? This decoupling architecture is achieved by creating some interfaces between your microservices, right? Yes. So by creating some constant interfaces between your microservices, we can able to provide communication between them. So how we provided communication between our microservices? By using some event driven architecture. By using some event driven services, we can able to provide communication between our microservices. Even if we use this event driven architecture, it can able to provide communication between single source to multiple consumers. From single source to multiple consumers, communication it will provide. Nothing but coordination it will provide. So what is this event driven architecture? Why we are using this event driven architecture in addition to decoupling architecture? To increase the decoupling facility, and to connect to multiple destinations, we have this event driven architecture. In this event driven architecture, you can see we have three main components, that is source, and one more is event mediator or event driven service or event coordinator, and the third one is consumer. This is one component, this is another component, this whole thing we call it as one more component, that is consumer component, or you can say in technically in AWS, we can say it as target. Now, by using this mediator, event mediator, or you can simply say this event mediator as event coordinator, which provides you coordination between your event source and your event consumers. It can able to this event coordinator can coordinate all the events sent by this event source to event consumers. So this is what happened in it. First, event source, whenever event source generated any event. So now let's have a question. What is an event? Every action, we call it as an event. Let's say if we consider S3, if we create a bucket in S3, then we call it as an event. Let's say I uploaded one object in my S3 bucket. We call it as one event. That is, uploading object is one event. If we download one event, that is also one event. So everything, every action will be one event. If we consider EC2, if we create an EC2, then it will convert from running state to pending state to running state. So while launching, it was in pending state. After launching, it converts to running state, right? Yes. So that conversion from one state to another state also, we call it as an event. So those all are events. So from multiple sources, we'll get events. Then by using this event coordinator, we can able to coordinate these events to single or multiple consumers. So in today's video, let's focus more on one of the event coordinator service. That event coordinator service is Event Bridge. What is that? Event Bridge. So let's focus more on this Event Bridge and let's learn in depth about this Event Bridge. This Event Bridge acts like a event coordinator between our event source and our event consumers, or you can say targets. So what is this Event Bridge? It acts like a event coordinator between your event source and your event consumer. If we focus on real time, then in real time, where our actual applications will run. Let's say I utilized AWS services, then my application runs on either AWS services. Let's say I utilized another external software as service providers to run my application, then where my application will be in external service providers. So they also may be one of the sources. Now let's say my application is running on consumer applications. So can I say those consumer applications also one of the event sources? Yes. So for my applications, these are the three types of event sources. What are they? AWS services or external software as service providers or custom applications. So these three are the event sources. These three comes under my event sources. They generate event for my application. They are the sources to generate event for my application. Now let's move some more detail about what this event bridge can support for AWS services. For what AWS services this event bridge supports. That is, this event bridge can accept the services as a source, right? Yeah. So what AWS services, this can accept, event bridge can accept as sources. So this event bridge can accept AWS services as sources where your source is lambda function, then this event bridge can accept that lambda function as your source, or Amazon Fargate, then that service also it can accept as source to generate the events. And Kinesis also, it can consider that Kinesis as one of the event source as well. So like that, totally 90 AWS services this event bridge can support for event sources. So currently this AWS EventBridge supports totally 90 AWS services as event sources. If we focus on external software as service providers as event sources, then this event bridge supports up to 30 external. So currently it was supporting 30 external software as service providers as event sources that include Gendex and Auth0 and so on. So like that, many event sources will be supported. Many software as service providers will be supported by using this event bridge. Whereas coming to targets, so what is the role of target, sir? The role of target is, so based on the event happened in the event source, our event will be routed or coordinated by using this event bridge to the targets, right? Yes. So after moving my event to target, that target may need to perform either one target or multiple targets that need to perform the complementary action, right? Yeah. So complementary action, or we can perform any subsequent or corresponding action by using that service, right? Yeah. So what are the destination services this event bridge support? How many destination services this event bridge supports, sir? Currently, this event bridge supports totally 15 targets. So don't count like it's just supporting for less number of targets, because in these targets, it also supports you step function. If you use that step function as this event bridge target, then by using that, you can even trigger more services. So not only this, it also includes step function. So we can even calculate the additional services which are supported by step function, right? In order to trigger by using this event bridge. So we just trigger by using event bridge to step function. Then that step function can trigger other services, right? Yes. So those all comes under this category. And directly this event bridge supports targets as Lambda function or EC2 instances or Kinesis streams and so on. So like this multiple, that is up to 15 currently it is supporting. Based on your requirement, you can able to use any one of the service, any one of the AWS service or external software as service provider application or consumer application events as event sources and event bridge as your event coordinator, and you can use target to perform corresponding action by triggering by using this event bridge. So now let's have a question that how this event bridge can able to trigger particular AWS targets. So in order to configure that, in this event bridge, we have two important components. What are they? Those two important components are event bus and rules. So what is this event bus, sir, and what are these rules? This event bus is nothing but this is where our actual events are landed. So whenever our event sources generates an event, then those actual events are lands on these event buses. Then this event bus is even associated with rules. Then this event bus is even associated with the rules. So in these rules, we actually trigger to our targets. So in these rules, we define to where we are triggering. We can even trigger to one target, or we can even trigger to multiple targets by using this rules group. So let's see types of event buses we have. So some more, let's see some more detail about these event buses. We have three types of event buses. Let's say if you are expecting to capture AWS services related events, then we have default event bus. So there we can able to capture. Let's say I have some custom applications. Now I am expecting to land the events that are generated by these custom applications inside my event bridge. Then you can choose this custom event bridge, custom event buses. these custom event buses you have to create and you can able to use. So after creating these custom event buses, you can able to use and you can able to land what are the custom application events that are created. Let's say you want to store, that means you want to land the events which are generated by software as service provider. That is this. Then this event bridge also supports you software as service provider event buses. So there you can able to land your events. Then after, so for each bus, you can able to associate up to 100 rules. Up to 100 rules only you can able to associate to a single event bus. In that rule, you can able to define to which target you want to trigger. Which target you want to trigger that you specify in this rules. So whenever a event generated by your event source that first lands on your event bridge event bus. So whenever it lands on your event bridge event bus, so in that particular event bus, so what rule you have associated to that event bus, based on that rule, the multiple targets or either single target will be triggered. So based on the rule targets you specified. So while creating rule, you need to specify your targets, and so in order to trigger multiple targets, you need to attach your rule to whatever the event bus that you created. So then only whenever an event is generated by event source and place that event under your event bus, those all targets will be triggered and your respective corresponding actions will be taken with respect to source event. So this is what happens inside your event bridge. Now the limitations here is you can associate only up to 100 rules to a single event bus, and in a single rule you can able to trigger, you can able to write up to 5 targets only. That is, you can able to, by using single rule, you can able to trigger only 5 targets. That means by using single rule, you can able to trigger 5 targets. Let's say I have created a event bus, and inside that event bus, I have attached 100 rules. And inside the each rule, I have triggered totally 5 targets. So totally how many targets I can able to trigger by using a single event bus? 5 into 100, that is 500 event, 500 targets I can able to trigger at a time by using a single event bus. So by using a single event bus, we can able to trigger those many targets by creating rules, and inside my rules by defining the targets. Okay. So let's see the triggering types. So how many triggers are there, sir? So I told you, right? We can able to trigger targets by using the event bus rules, right? Yes. So whenever after creating the event bus, how many ways do I have to trigger my targets? You have again 2 ways. First one is event based trigger and second one is scheduled based trigger. So you have seen event based trigger. A event happened in event source. So that causes to store, or else that event will be stored under your event bridge, event bus. So whenever that event is landed in your event bus, either default event bus, then whatever the rule associated, that rule related targets will be triggered. So that is the event based triggering. So what is the schedule based triggering, sir? In the schedule based triggering, the triggering of your targets happened whenever you schedule. That means you can able to schedule certain period of time and you can able to trigger your targets in that moment of time. So by using the schedule based time triggering, you can able to trigger your targets based on schedules. You can able to schedule particular number of days, or you can able to schedule particular number of weeks, or you can even able to trigger your targets by scheduling particular number of months, by specifying months. So based on days, weeks, and months, you can able to schedule your triggering also. That is nothing but scheduled based triggering. Now, now let's discuss more about, let's move in depth about how our events will be. So who generates the event? Event source, right? Yes. So what are the event sources? I have AWS services as well as software as service providers, and consume custom applications are my event sources. Now, how my events are? So before, after placing, or before placing, how my events are. So let's say after placing in my bus, how my events will look like. They will be look like a JSON script. How they will be? They look like some JSON, or you can say ML script also. Some services, some AWS services even provide the events in the form of ML script also, that you can able to configure as well. So actually your event related data is stored in the event bridge event buses in this format. That is either JSON format or ML format. Let's say you are using some of AWS services, then you can even configure the events, that is in which format you want to provide the events to your event bridge. So those things also you can able to configure if you are using AWS services. Let's say you are using external services or custom services, some may not provide you that option. So basically your data or request will be transmitted in internet in the form of JSON, because it's a easy language. So this is how API calls between two applications will be happened. By using JSON script only, API calls will be happened on your actual real-time environment in applications. Now we have already told you that these events are stored under your event bus, right? Yes. So in order to store your events, that is a JSON script or ML script under your event bus, this event bus need to be in the same format of the script that you are sending, right? So then only it can able to store your data, right? Yes. So the destination, the event bus data storing format also need to be same as event source format, right? Yes. So we can say that format as schema. So in order to store your schema, under your event bridge event buses, we have two options available. Those are manually we can able to create our custom schema, or we can use the existing AWS owned schemas, where in that schema you can able to store our, or we can able to land our events related data in this event bridge event bus. Now let's focus on one more important point when managing our applications in real time. That point is event, that is nothing but disaster recovery. Sometimes our databases, so what are the databases we have, they may losses or damage happen sometimes. Even our application loss sometimes. That is, our applications may loss or damage happens in real-time environment, right? Yes. So at that scenario, we need a recover backup, right? Yes. So we need to recover back. It is even very difficult. We do not have events that we done previously, right? Yes. So in order to recover back, we need to know what events done. So this database or my application will be damaged. So those events I need to audit and I need to recover back, right? Yes. So in order to get those events, for that also we need to store whatever the events that are sending by our event sources, right? Yes. So in order to store the events, so to store the events which are landed on my event buses, does this event bridge provides me any facility? The answer for this is yes. So in order to store the events for certain time, that is up to some retention period, we have an option which is present in AWS Event Bridge, that is archives. What is that? Archives. In that archives, you can see in that archives, by using this AWS Event Bridge archives, we can able to store, our data till retention period only. So till the certain amount of days or time, we can able to store our data of events under this event bridge archive. So after the retention period that you specified, all the events that are present in this event bridge archive also deleted. So based on your requirement, you can able to store the events up to how many days you want in this event bridge by specifying some retention period. Whenever we require, after storing your events in this event bridge archive, whenever we require any recovery in your database losses or application losses, we can able to recover them back by using the previously stored events in archives, right? Yes. So by using those events, we can able to recover back by taking the necessary actions or performing certain required actions to move back from damage to normal healthy state, right? Yes. So we have one more option, that is replace. What is that? AWS Event Bridge replace option is also available. By using this replace, we can reprocess past event from archive. We can even reprocess past events from our archive. We can, so in that way, by reprocessing our past events from our archives, we can even able to recover the databases or applications which are damaged. So after running this replay option also, you can able to cancel that. Whenever this replay option is even running. So that facility also you have. Whenever you use this archives to replay to event data recovery, or so to recover your databases or your websites, so that can be able to done by using this replace, by storing your events under your archives, and after running your replay also, you can able to cancel that replay at any time whenever your replay is running also. So this event bridge also provides you recovery from disasters for your databases as well as websites by using these two options, that is replace and archives. Archives will store your data, events data, and this replace will roll back, or you can say reprocess past events from your archive. So in this way, you can able to recover your environment. Or you can say your infrastructure. So this is all about your event bridge. I have even highlighted the important points. So in monolithic architecture, scaling will be difficult. So in order to overcome that, we move for decoupling architecture. It is easy. If we move to decoupling architecture, to connect to multiple destinations and to increase decoupling facility, we use event-driven architecture. You can see that's why we implemented our decoupling architecture under your, that is event driven architecture under our decoupling architecture. So we can even say that as microservices architecture, since we are working on microservices as individual layer, we can call it as microservices as well. So here we focused on one more example, that is one decoupling or one event driven architecture example, that is event bridge. How this event bridge will act as? It acts as event coordinator, and event sources may be AWS services or custom applications or external software as service providers. And if we focus on AWS services, then it supports us 90 AWS services. If we see external software as service providers, then it supports 30 different external software as service providers. And to route the events to targets, we have rules. If we focus more on event buses, we also have event buses in order to land our actual events. So that I want to highlight. So events actually land in where event buses. So one second. Events actually land. So I'm highlighting that as well. Okay. So if we focus on event buses, then this AWS provides us, this event bridge provides us 3 event buses, that is default, custom, and software as service provider event buses. And by we can even trigger the events, that is we can even trigger our targets by using these event buses in these 2 modes, that is by using event triggers or else by scheduling to trigger in days or weekly or monthly. And this event bridge supports up to 15 targets. This event bridge supports up to 15 targets in AWS services. That is, it supports up to 15 targets. We can able to use those 15 services as targets to trigger them. And coming to hard rules regarding a rule, in rule we can able to, by using a single rule, we can able to trigger up to 5 targets, and by using a single bus, we can able to associate up to 100 rules. So totally by using a single bus, we can able to trigger 500 targets. And we can see, even we have studied about schema, about event. So how our actual events will be is in the form of JSON script. So in order to store those events in my event buses, I need to have exact schema, right? Yes. If you are using AWS services as your sources, for those sources, already you have existing schema, that is AWS owned schemas available. You can able to use them. Or else, if you are using any custom or that is custom applications or external software as service providers as your sources, and you don't have schema related to that, then you can have another option, that is manually providing option also available to you to create your own custom schema. And for event recovery, that is events data recovery also available in here, where you can able to store your events up to certain retention period in your AWS Event Bridge archives, and you can even able to replay them. So by replaying, you can able to reprocess past events from your archives. So that is the advantage about this archives and AWS Event Bridge replace. So this is all about a theory regarding event bridge, where this event bridge acts as an event coordinator between your event source and your event consumers. In AWS, we call those event consumers as targets. So I hope you understood this video and you got a good knowledge on this event bridge. So one more special use case of it is external service providers. Whenever your event sources are external service software as service providers, then this is the best suitable service in AWS for event coordination So by using this, you can even able to do some transformations as well and filtering of your events as well by using this event bridge. Those two also you can able to do by using this event bridge. So this is about your event bridge AWS service. I hope you understood this event bridge and you also understood this event driven architecture and a small comparison between your monolithic and microlithic, that is a decoupling architecture as well. So I hope you understood this video and you got some knowledge or knowledge recap from this video. If you like this video, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video. Until then, bye bye, guys.